Next question. What is the next question? State and explain Huygens principle of secondary wavelets. So this will come in wave optics. Question number. What is that? Question number 27. Question number 27. So here 2 points are there. First one is every disturbance is a new source. Each point on a wavefront. Sorry, each point on a wavefront is a new source for another secondary wavefront or another secondary wavelet. That is the first point. Each point on a wavelength, secondary wavefront, each point on a wavefront is a new source of another disturbance or another wavelength. That is one point. Other point, wavefronts emitting from the source of secondary disturbance will travel in all possible directions with all possible speeds. That is the second point. Wavelets emitting from the secondary source will travel in all possible directions with all possible speeds. That is the second point. Here two points are there. So first one is each point on a wavefront is a new source of secondary disturbance. That is the first point. And second point is wavelets emitting from the source of secondary disturbance spreads out or travels in all possible directions with all possible speed. That is the 2 points. Huygens theory is stated like that. And here wavefront definition also we need to know what is that wavefront definition. Continuous locus. It is a continuous locus of all the points. Wavefront definition. Continuous locus of all continuous locus of all the points vibrating in the same phase. Continuous locus of all points vibrating in the continuous locus of all points vibrating in the same phase. Vibrating in the same phase, that is called as wavefront definition. So next, question number 28. What is question number 28? Write any two drawbacks of Bohr's theory. In the atoms topic, it will come. Bohr's atomic model postulates and limits very important. Postulates also they have asked here in the next main. So here drawbacks. First drawbacks, it is applicable only for hydrogen kind of atoms. It is applicable only for hydrogen kind of atoms. Second one is it fails to explain the fine structure of hydrogen atoms. So it fails to explain the fine structure of hydrogen atoms. First one is it is applicable only for hydrogen atoms. It is applicable only for hydrogen kind of atoms. Second one, it fails to explain fine structure of it fails to explain fine structure of spectral lines. It fails to express fine structure of spectral lines. In chemistry also it will come. Bohr's atomic theory postulates and these drawbacks, limitations, and demerits, not a disadvantage, demerits, all are same only. And it is applicable. It fails to explain the stability of atoms, stable orbits, sorry, not atoms, stability of orbits, stable orbits. It fails to any two. You can write the first two. That is question number 28. Next, question number 29. What is a nuclear fission? And we will give one example. So, what is that nuclear fission? Fission, the name itself indicates a breaking up of heavy nucleus and it will give small nucleus. That is called as nuclear fission and fusion. Two kinds are there here. So, first one is fission. Nuclear fission, and the next one is fusion also will come. Fusion means combining two smaller or lighter nuclei will combine each other and they will produce one heavier or bigger nuclei. Here fusion, one large nuclei, it will get bombarded by some electrons, sorry, neutrons. It will give two smaller another two nuclei. That is called as the process of breaking up of heavy nucleus also we will say like that only. So nuclear fission. So the process of breaking of heavy nucleus into two or more smaller nuclei with some amount of release of energy, that is called as nuclear fission. One example they have asked, for example, 92 uranium 235, you can bombard with one neutron, so total it will become 92 uranium 236. This will break up and it will give barium and krypton. It will give barium and krypton, Kr, barium and krypton. So the atomic and mass numbers are 56 141, 56 141, and 36 92, 36 92 plus 3 times of 1 0 neutron. So this is one example for nuclear fission. You can add up same thing should come 92 to 36. 56 plus 36 92. This is 141 plus 92. Here 3 are there. 3 plus 2 5 1 6 49 23. It will balance the equation. So balancing the chemical equations is very important in chemistry. It will come. Okay, this is nuclear fission and one example. So next part C. Part C contains 3 marks questions. What are that? Part C, fourth main, part C, fourth main, fourth main, part C, fourth main. First question: find the resultant electric field due to a system of charges using superposition principle. What is superposition principle states that the net electric field is equal to E net. The net electric field is equal to sum of the electric fields due to individual charges E1 plus E2 plus E3 plus etc. of 2 plus En, like this. The net electric field due to a system of charges is equal to sum of the electric fields due to individual charges. We know that the general equation for electric field is E is equal to 1 divided by 4 pi epsilon naught Q divided by R square. That is E. So E1 you can similarly like that you can write E1 and E2. E1 is 1 divided by 4 pi epsilon naught Q1 divided by R1 square. Similarly E2 you can write E2 is equal to 1 divided by 4 pi epsilon naught Q2 divided by R2 square. So diagram is net electric field due to a system of point charges. So you can consider one point charge here, other point charge here, Q1, one point charge here, Q2. Diagram also is a necessity required. Q3, Q4, etc. It will come like this. From here to here, what is the distance? From here to here, what is the distance like this? So R1, R2, R3 and R4. Similarly, etc. of 2, En is equal to 1 divided by 4 phi epsilon naught Qn divided by Rn whole square. You can combine, substitute all these values here in this equation. Then the net electric field En is equal to 1 divided by 4 phi epsilon naught is common in all the equations. You can take outside. 1 divided by 4 pi epsilon naught is common in all the equations. You can take outside. So what is left? Q1 divided by R1 square plus Q2 divided by R2 square plus etc. of 2 plus etc. of 2 plus Qn divided by Rn square, like this. Now, so here En is equal to 1 divided by 4 phi epsilon naught, the very easy one. If you know the mathematics, in mathematics this kind of equations are most expected everywhere. Equations came. So now this can be written as, now in terms of summation, it can be written as using mathematics summation of qi divided by ri square, qi divided by ri square. So actually this distance they will take it as, here one charge will be there, 1 2 1 2 R12, R13, R14, like that it will come, I think. 1 minute. Just a second.